Today we are going to be learning about simplifying and solving exponential equations, and what you need to be able to do is to recall your index laws, apply these to exponential equations, and then to simplify and solve exponential equations using these laws. So here's the summary of all of the index laws that you would have learned previously. First of all, if you multiply two numbers that have the same base, what you can do is add the powers. Likewise, if you divide two numbers that have the same base, you would subtract the powers. If you have a number that has a power and then you put it to another power, so you're multiplying it to another power, what you're going to do is multiply those two powers together. Anything to the power of 0 is equal to 1. If we have a number to a certain power, we can also rewrite it by bringing that number to the bottom and having a negative in front of the power. So a negative means it's moved to the other side. And of course, the inverse applies, that if I have a number to a negative power, if I move it to the bottom, the sign again changes. So these are all of your index laws that you would have looked at for the past few years, and this is what we're going to be using today. Example 9, solve for x in each of the following. So here we've got 4 to the power of 2x minus 2 is equal to 1. Now the simple trick with this is to be able to write values that have the same base. So if our numbers have the same base, then I can equate the powers. So how can I possibly write 1 as 4 to the power of something? Well, we know that anything to the power of 0 is equal to 1. So we can write this as 4 to the power of 2x minus 2 can be equal to 4 to the power of 0. I haven't changed the 1, I've just rewritten the way it looks. And because these two values now have the same base, I can equate the powers. So 2x minus 2 equals 0, 2x equals 2, and x equals 1. Next one, 2 times 3 to the power of x is equal to 162. So we're going to do the exact same thing where we're going to try and get the same base in. The first thing I'm going to do is that 2 is in the way, so I'm going to divide both sides by 2. So 162 divided by 2 will be 81. And then how can I rewrite 81 as 3 to the power of something? Well, that'll be 3 to the power of 4. Now that I have the same base, I can equate the powers. In this case, it's really nice. I don't even need to solve for x. X will equal to 4. Part C. This time we've got a large number on the left, 125 to the power of 2n minus 1 is equal to 5, 3 minus 4n. So once again, we want to try and use this technique of making the same base. In this case, I can see that 125 can be rewritten as 5 to the power of 3. But the issue is that I have this 2n minus 1. So we're just going to write it like this. So it's 5 to the power of 3, and then that's all to the power of 2n minus 1. Not sure why I wrote an x. I'll just fix that up. And then that's equal to 5 to the power of 3 minus 4n. But this is still not simplified. Now what I want to do is multiply the powers. So I'm using one of my laws. When I raise a power to another power, I'm going to multiply them out. So that'll be 3 times 2n minus 1 is equal to 5, 3 minus 4n. Don't forget to put brackets because there is more than one term. Now that the bases are the same, I can go ahead and equate powers, and I can solve for n from there. So I will start by expanding, then by collecting the like terms. So I'll take this to this side and this over to this side. 6n plus 4n is equal to 10n, and 3 plus 3 is equal to 6. Divide both sides by 10. That's going to be 3 on 5. Part D. What I can do here is I can use the null factor law because I have two values equal to 0. We know that if I have two values, a times b is equal to 0, the only possible way to get 0 is if a is equal to 0 or b is equal to 0 or both. So that's what the null factor law says. So I'm going to go ahead and do that. So either this must equal to 0 or this must equal to 0. From there, I can go ahead and get the values on the other side. And once again, I want to try and equate or create the same base. So in this case, 16 can be rewritten as 2 to the power of 4, and 4 can be rewritten as 2 to the power of 2, and I can go ahead and solve for x from there. And there I have my two answers. This one's a really interesting one. What I can see here is I do have different powers each time. So here I can see I've got a 2x, then a 1x, and then a no x. no x's there. Where have we seen that pattern before? So something to the power of 2, 1, 0. Well, hopefully you're thinking of quadratics. So x squared plus x plus a constant, which would be x to the power of 0. And that's exactly what this is. So in this case, what we're going to do is we're going to turn this into a quadratic by letting our base, so 3x, equal to a. So I'm just grabbing the base, 3x. We can ignore the 2 just for a sec. We'll use that, but it'll always be this number here. 3x is equal to a. The reason that I want to do 3x and not 3 2x is because I can rewrite 3 2x in terms of 3x. So that's just the same as writing 3x. Sorry, this will be 3 to the power of x squared. So I can rewrite it like this. And this, of course, is 3 to the power of x as well. And here is just a constant. I don't need to worry about that. So that's why I use 3 to the power of x. So in this case, 3 to the power of x all squared is the same as saying a squared. And then I've got a negative 12, and then there's 3x, which I can just write as a, and then I've got 27. Now, why that's really easy now is because this is just a quadratic. So what I need in this case is two numbers that multiply to give me 27 and add to give me negative 12. Those two numbers will be negative 9 and negative 3. So they can go straight into brackets. And then I can solve for there. But the thing is, I'm not solving for a, I'm solving for x. So at this point, I can go ahead and substitute in the fact that a is equal to 3x back in 3 to the power of x. So 3x is equal to 9, 3 to the power of x, and 3 to the power of x is equal to 3. And now I can proceed with the idea of equating the powers. And just to make that super clear, and now I can equate my powers here. So x can equal 2 and x can equal 1. Next example is going to be very similar. I would suggest try to pause the video at this point and give it a shot yourself. Okay, so hopefully what you've done is you have moved everything firstly to one side so we can make it a quadratic. And hopefully what you can recognize is we've got this situation again, 2x, 1x, no x, and that is our quadratic situation. So we're going to let a equal 3 to the power of x. So first of all, again, this is 3x all squared, and there's a 3 on the outside this time. So this can be rewritten as 3a all squared minus 28a plus 9 is equal to 0. This one's going to be just a little bit more complicated because I have a number in the front. So now what I want are two numbers that multiply to give me 3 times 9, which is 27, and two numbers that will add to give me negative 28. Well, hopefully you can see in this case, it'll look like the numbers are negative 27 and minus 1. They will multiply to give me positive 27 and add to give me negative 28. In this case, because there is a number in front of the a squared, we have to split the middle term. So this will be 3a squared minus 1a minus 27a plus 9. And now we will factorize by grouping. So here I can only take out an a, so that will be 3a minus 1 left over. And here I'll take out negative 9, so that will be 3a minus 1 left over. Then I can factorize again, so this is the common term. And what's left over is an a minus 9. And then I can go ahead and solve. So that'll be a is equal to 1/3 and a is equal to 9. Once again though, I'm not solving for a, I'm solving for x. So now that I know that a is 1/3 and a is equal to 9, I can go ahead and substitute this fact back in. So that'll be 3x is equal to 1/3 and 3x is equal to 9, to the power of x, I mean. So now what we want to do is rewrite the 1/3 and the 9 to have the same base. So 1/3, what you can see is that the 3 is on the bottom. I can take it to the top by making it to a negative power. And then same thing, well, it's not the same thing, but I can just rewrite this as 3 squared. Now I can equate the powers, and I have my solution. And that's it for exercise 5C.